Hello?
Hi there, how are you?
Good, and you?
Good, thanks. You can hear me clearly?
Yes.
Okay, let me just shut the door in my office. Hang on.
Okay.
Okay, so thank you for putting that question up on the board.
Mhm.
So the tanagram and its side length is 10, so that's the outside of the figure.
Mhm.
What area is figure F? Okay. How long is each side of the square? All right, so have you done any of these questions at all?
No.
Sorry, I can't hear you. You haven't tried it?
No. Well, I know what, I've tried it, but, I didn't answer any of these questions. I didn't answer A, I didn't answer B, I didn't answer C, or D.
Okay. Well, why don't we start with question A? So what is the area of figure F? Now we see figure F on the board, right?
Mm-hmm.
And what geometric shape do you think it looks like?
A square.
Okay. Now the problem with the side lengths is that we're cutting through diagonally, correct?
Mm-hmm.
Okay. Just give me a second. I just want to think about this because I'm not sure if I'm going to break this up into something smaller. So give me a minute, okay?
Okay.
Okay, I'll be right back. Hang on. Okay, so I'm back. Can you hear me?
Yeah.
Okay, have you done Pythagorean theorem yet?
Yes.
Okay, well, there's a few ways that you can go about figure F. Now I'm going to draw on figure F. Now, do you see the red line that I've moved across figure F?
Yeah.
Okay, do you see that we can take figure F and break it into two triangles?
Yes.
Okay, and if we broke this into two triangles, do you know what the formula for area of a triangle is?
Base times height divided by 2.
That's right. Now, if we look at the base in red, what would you see? What would you say the base is?
Well, I would say it's, we don't know, right?
Well, what is the length of the outside of the figure?
10.
Which means every box is worth how much?
10.
Okay, hang on a second here. I'm just going to use
Oh,
little
wait,
black.
I thought 10 was like this. Like the outside.
It
This
is
is
like
10.
do you see that black line that I'm putting across on the top of the shape?
Yeah.
All that is 10, correct?
Yeah.
Okay, now do you see that that is broken up into smaller, whoops, the
Sorry.
everything just left. There we go. Do you
Okay.
see that that's broken up into smaller little blue boxes
Mm-hmm.
inside the shape, right?
Yeah.
How many blue boxes do you see running across?
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Okay, hang on. I'm going to number them. Do you see the numbers appearing?
Yeah.
Okay, so do you see how I'm counting the boxes here?
Yeah.
Okay, so if I'm going to go across, how many do we have in total?
100.
No, just across in one, like,
Oh,
like
10. 10.
10.
Yeah.
And then if I were to do it this way, do you see that arrow that just
Yeah.
appeared in black?
Mm-hmm.
How many are there that way?
10.
Right. So keeping this in mind, how do I make that reappear? Can you make that picture reappear? There we go. Okay. So keeping this in mind, do you see that red line inside the F square?
Yeah.
Okay. So if I'm going to number this 1, 2, 3, 4, 5, do you see those numbers appear inside?
Yeah.
Do you agree that if we were to break this triangle up, the base of that triangle is 5?
No, I don't know where you're getting 5 from. You just counting the grid?
Exactly.
Oh.
Because they're saying that the side length, if you take a look at your original question, it says that its side length is 10 centimeters. So all of this is a 10 centimeter by 10 centimeters. And you can tell by just counting the boxes across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then downwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Mm-hmm.
Okay, so if I'm going to consider that smaller shape, so I'm going to bring it over here, because the first question tells you to calculate the area of the square. And the problem is that they have slanted it. It looks like a diamond, right?
Yeah.
That kind of messes you up.
Mm-hmm.
So you have to find either the side length that is a slant using the Pythagorean theorem, or the other way that I'm suggesting is to slice these into two smaller figures. So do you see that I've just put down here?
Yeah.
Okay, now I'm going to put some color here in red. Okay, do you see in red that just appeared?
Mm-hmm.
What's that length?
5.
Right. Now I'm going to put it in green. And if we do the height, you see the green that just appeared?
Yeah.
What's the height?
Would that be, you would do 5 divided by 2, which is 2.5.
That's right. Okay. So do you see how the height is 2.5?
Yeah.
And the base is 5. Do you agree?
Yes.
So would we be able, with these two values, to calculate the area of the top triangle, like the triangle that makes up the shape? Like this shape is made up of two triangles, right?
Yes.
Okay, so if we're going to calculate that area, the area would be base times height divided by 2, correct?
Yeah, when you multiply that by 4.
Well, hang on a second. If I did base times height divided by 2, I would end up getting, do you see where I'm slashing all across here, this triangle?
Yeah.
That would give me that portion. Do you agree?
Yes.
Okay, so what's the base worth?
Okay, so the base is 5.
What's the height?
2.5.
And then we divide that by 2, so grab your calculator.
Okay. And I got 6.25.
Right? So that would give you 6.25 would be the red now where I did the slashing part. Now let's do the bottom in green. Do you see where I'm slashing the bottom in green?
Wait, wouldn't that only be 1? That'd only be 1, it wouldn't be 2.
What do you mean 2?
Because like, this is the green, right? Is that what you're doing?
Well, do you see that shape, that square in blue that we're looking to calculate the area?
Yeah.
Do you see that you can fit two triangles on the inside? Do you agree?
Oh, okay. I get it.
Do you agree?
Yeah.
So the top
it.
and the top portion of this triangle is in red there. That is lined up in red.
Yeah.
And that area is a total of 6.25 because we know the base and the height, correct?
Yeah.
What would be the area of the bottom portion of this, like the bottom triangle?
It would be 12.5.
Does it have, what's that?
12.5.
Well, does it have the same base?
Yes.
Does it have the same height?
Yes.
And then do we divide that by 2 because it's a triangle?
Yes.
So would it be the same area that we just calculated?
Yeah.
Okay, perfect. So what do we do with those two values?
Well, you would just add them together.
Exactly. So what's 6.25 plus 6.25?
12.5.
Exactly. Got it?
Yeah.
Okay, so that takes care of that figure.
Mm-hmm. So what's the area of figure F would be 12.5, and it says how long is each side of the square? So each side of the square would be 5.
Okay, each side of the square. Well, the thing is that I guess this leads you into the other way that you could have calculated this, which is a little bit more complicated.
Yeah.
Do you see where I'm adding the orange?
Mm-hmm.
For you to be able to calculate how long is each side of the square, you need to find that orange portion, right?
Yeah.
Now, because that's a slant, that means we would have to forcibly use the Pythagorean theorem. Okay, so if I'm going to recreate another one of